So welcome to Unit 13. In 13.1, we're going to be plotting real-world functions in standard form, right? We've learned what standard form is, ax plus by plus c, and we're going to apply that to the real world. We've already done that for y equals mx plus b. Now there are situations where that's better explains the real world than what slope-intercept form. All right, so we got to remind ourselves how to find intercepts. We're going to graph that, right? So to graph that, the fastest way is find the intercepts. For the y-intercept, you make x coordinate equal to 0. Right, that goes away. You divide both sides by -3. Y equals -8. So the y-intercept is 0, -8. To find the x-intercept of that, you make the y-coordinate 0. You divide both sides by 4. X equals 6. The x-intercept is 6, 0. We draw a line between those 2 points. Okay. And that is the graph of 4x minus 3y equals 24. Solve your equation to determine what the value of y was when x equals -3. All right. So when x equals -3, we're right there. We're going to figure out what that point is. Okay. Let's see. So we're going to put 4 times -3 minus 3y equals 24 in there. So 4 times -3 is -12 minus 3y equals 24. Right? We're solving this for y. We're finding the y coordinate. So we're adding 12 to both sides. -3y equals 36. Divide both sides by -3, and y equals -12. So when x is -3, y equals -12. And we can do that for any point along this line, right? We could put, let's see a good one. Well, there's a good one right there, +3. We put +3 into this equation, we better get -4 out, right? And we can figure out any point along the line that way. The reason we use the intercepts is because they're the fastest points to find, because 0 makes the math, right? This math was easier than this math, and they're the easiest to graph, because if you were making a sketch of this, right, to graph it, you go 1, 2, 3, 4, 5, 6, boom, 1, 2, 3, 4, 5, 6, 7, 8, done, and there you have a sketch. Hopefully yours is better than mine. All right, so now we're going to apply the real world. Now notice, there's no arrows on the end here because negatives don't really make a sense. This is a graph of adults and children. There was a mixture of adults and children who bought movie tickets. All right, so right there, 0 children bought movie tickets. What each one here is going up by 2, yeah, and 10 adults bought movie tickets. Down here, 20 children bought movie tickets and 0 adults. All right, 20, 0, 0, 10. Those are intercepts. Okay. And this is a graph of all the possible combinations of adults and children that could have gone to the movies for $100. And that's what this 100 is, and you'll find out that in a second. All right. If 10 people went to the movies, I'll explain the notes in a second. If 10 people went to the movies, write a linear function in standard form. So we're using ax plus by equals c, but we're not going to use x and y. We're going to use real world variables. Write a linear function in standard form to show all the possible combinations of adults and children that could have attended the movies. All right, so let's think about that. If adults and children are going, right, let's make a little t-table. All right, children is on the x-axis. Right? If 0 children go and 10 total went, you could have 0 children, 10 adults. If you have 1 child go, then you have 9 adults, right? And 2, 8, and I'm not going to do them all, but if you have 10 children, 0 adults go. And if you have 9 children, 1 adult can go, all right? So what is the equation of that? Well, a plus c must equal 10, right? So let's graph that, right? What are the, now that's standard form, so we use the intercepts, right? I already gave them to you, right? 0, 10, and 10, 0, and we connect those two, and that's a graph of all the combination, right? Right there is 8, 2. The truth is there's 9, 1. It's not at a good intersection, but right there is 6 children and 4 adults, because they have to add up to 10. They're on the line here. This is 4 children and 6 adults, right? And so on. And this is the intercept 0, 10, and this is the intercept 10, 0. All right, now that's a very simple one, but they're all like this, and they're all going to look like this in the first quadrant. Okay, so when we do this, the rates, there are going to have to be two rates in the problem. There were no rates in the first one, but in most of them, there are going to be two rates, and they're going to be our coefficients. So, right, if there's a rate, I've always said it's the coefficient. Well, now it's there are two rates, so there are two coefficients. So let's see that. Movie tickets cost $12 for adults. Right now we have the price of the tickets, and $8 for children. If we want to spend exactly $120, write a linear function in standard form to find all the possible combinations of tickets. So A stands for adult tickets, right? It's the number of adult tickets. So let's just define our variables. And C equals the number of children's tickets. Now, of children, not adults. Now we have rates. So what is the 12 the coefficient of? It's $12 for adults. It's 12A. It's $8 for children. What's that the coefficient of? C. And it's, right, the total, what's the total amount of money we spend? That's the linear function. That's the line for a combination of adult and children's tickets that add up to $120. Okay? All right. Let's do another one. A school wants to give away t-shirts to their students and has exactly 300. So that's the total we have to spend. Heavyweight t-shirts cost $10 per shirt. So the coefficient of H is 10. Cheap t-shirts cost $6. The coefficient of C is 6. Write a linear function in standard form, right? It's going to look like this. AX plus BY equals the total every time. A and B here, these are our coefficients. They're our rates. There are rates. And we're not using X and Y. We're using H for heavyweight and C for cheap. And what this means is if you buy more of the heavyweight, you have to buy fewer of the cheap. And if you buy more of the cheap, you have to buy fewer of the heavyweight because you only have $300 to spend. All right, so now we're going to graph that. So how would you graph that? Well, it's in standard form. So let's graph when H equals 0. Okay, H is on the y-axis here, but H equals 0, so it would be 10, 0, that cancels out, plus 6C equals 300. So when H equals 0, all right, we're going to divide both sides by 6. C equals 50. So when H equals 0, C equals 50. So that's, I did the x-intercept first, which I shouldn't have, because I'm always doing the y first. All right, and then here, we're going to make C equal to 0. So when C equals 0, we get 10H plus 6 times 0 equals 300. Divide both sides by 10, and H equals 30. All right, so when if you buy no cheap shirts, you're going to buy 30 of the heavyweight. Okay, so notice if you buy heavyweight, you only can get 30 because they're expensive. If you buy the cheap, more people can get t-shirts, right? But you know, they're cheap. Do people want the cheap t-shirts? These are the decisions people have to make. And then maybe you want to get some mixture of the two, right? Like right there, you could buy 25 of the cheap and 15 of the heavy, right? Maybe the people that did the most work for the school get the heavyweight ones, and then there's other people who you want to give something to, but they get the cheap shirt. Okay. Okay, so a company wants to create a mixture of nuts that sell for exactly 40. So the total amount of money we got is $40. Peanuts cost $2 per pound, 2p. There's our coefficient. And cashews cost $5 per pound, 5c. That's our equation. So now I'm going to do the y-intercept first. So I'm going to make C equal to 0. So when C equals 0, we get 2p plus 5 times 0 equals 40. Divide both sides by 2, p equals 20. So 0, 20 right there, right? P equals 20 is right there. When p equals 0, we get 2 times 0 plus 5 times c equals 40. Divide both sides by 5. C equals 8, right? 40 divided by 5 is 8. And so that is 80 right there. And then we connect the two, and those are all the possible combinations of peanuts and cashews that add up to exactly $40, right? You can see right there, we could do 4 cashews and 10 peanuts and some other combinations along there. All right, Fred wants to know all the combination of dimes and quarters that can make exactly $5. Okay, so that's the rate a dime is worth. The rate of a dime is 10 cents per dime. That's its rate. So let's use D for dimes, by the way. So 0.1 D, all right, yes, all right, a dime is worth, that's 10 cents. You could leave the zero if you want to. And quarters, its rate is 25 cents. Let's use Q for quarters. It has to add up to exactly $5. Now, we can graph that. Now, can we clear the decimals of this? Yes, you can. So you move it twice in all of them, right? Oops. And so you could have 10D plus 25Q equals 500. That also, right? And why would you do that? Well, it makes our math easier so that when we write Q equal to 0, right, you get 10D plus 25 times 0 equals 500. Divide both sides by 10. And so D equals 50. When D equals 0, you get 10 times 0, that crosses out, plus 25Q equals 500. Divide both sides by 25. 50 divided by 25 is 2, and 500 divided by 25 must be 20. So there's our combinations, and hopefully there is the graph. It says if there are 10 quarters, evaluate the number of dimes. Well, if you want exactly $5, right, you better have 10 quarters goes with 25 dimes to make exactly $5. Right, and you could put that into any of these equations, right? You could do 10 times D, which is 25, plus 25, I'm using this equation right here, times 10 quarters. That will equal exactly $5, 500, right? Because that's 250, and that's 250, and that adds up to 500. All right, a 12-ounce mixture of coffee beans has both mild beans and robust beans. So coffee almost always is a mixture of beans. Robust means flavorful. Flavorful beans are more expensive, all right? But in this case, this is just like the very first problem we did. In this mixture, there's mild beans and robust beans, and they have to add up to 12. That's the linear function. There's no rates here. That's as easy as they get. M plus R equals 12. All right, a store sold $1,200 worth of jeans. The popular jeans were $40 a pair, 40p. And the cheaper jeans were $30 a pair, 30c. Write a linear function, and we spent a total of $1,200. There's your linear function. Write a linear function in standard form to show the possible combinations of popular and cheap jeans. Okay, so if we make c equal to 0, we get 40p plus 30 times 0 equals 1,200. Divide both sides by 40. 12 times divided by 4 is 3. 120 divided by 4 is 30. So P would equal 30 right there. If P equals 0, sorry, I didn't give myself enough room here. We have 40 times 0 plus 30C equals 1,200. Divide both sides by 30. 12 divided by 3 is 4. 120 divided by 30 is 40. So C would be 40. There's our intercepts. All right. There were all the combinations of popular and cheap jeans that cost exactly $1,200. Okay. If we sold 15 of the popular, that's this one over here. How many of the cheap did we sell? We sold 20 of the cheap. You can see it right there. 20 cheap goes with 15 popular. All right, cheap's down there. Now again, you could solve the equation. You could do 40 times 15 plus 30C equals 1200. 40 times 4 times 15 is 60, by the way. So 40 times 15 is 600. All right, and then subtract 600 from both sides. Subtract 600. 30C equals 600. 1200 minus 600. And divide by 30. And we hopefully get 20. Cheap. Which you can see on the graph. Okay, so final question. So nickels are 5 cents, right? Quarters are 25 cents. And we have exactly $1.50. That's our standard form linear function. If you want to clear the decimals, you have to move everything twice in every term. You have 5n plus 25q equals 150. All right, when q equals 0, 5n plus 25 times 0 equals 150. Divide both sides by 5. N equals 30. That's this point right there. When n equals 0, you have 5 times 0 plus 25q equals 150. Divide both sides by 25. 25 goes into 150 6 times. So there's 5. So 6 would be right next to it.